Hello everyone. So here is another problem on basics of induction motor. Here you see example number 34.5 and then I have some problem listed here. So this is again the description of the book. The information of the book I'll leave it in the description. So let's get to the problem and we'll start it. Okay, a 12 pole 3-phase alternator driven at a speed of 500 r. Okay, by the way, so this is the keyword here, alternator. Alternator is not induction motor. Induction motor is different. Alternator is actually an AC generator. So, uh, so if I want to draw a diagram, there is a prime mover. Some kind of prime mover is connected to a synchronous motor. And this particular synchronous motor, the information is given, is a 12 pole 3-phase synchronous motor. So here P equal to 12 and then 3 phases. Frequency is not given and it is driven at the speed of 500 rpm. Okay, so this is a synchronous motor. Supplies power to, by the way, so the input is mechanical. This is actually synchronous generator. It's not a motor. The term alternator is nothing but synchronous generator. Alternator is equal to, so alternator is nothing but synchronous generator. Okay. Now what is the output of synchronous generator? The output is a 3-phase power supply. So I get a 3-phase power supply. This is electrical. Now this electrical output is again connected to an induction motor. So I connect the 3-phase supply to the induction motor. Okay. Driven at 500 rpm, supplies power to an 8-pole 3-phase induction motor. So here poles are equal to 8. Okay. Frequency is again not given. If the slip of the motor at full load is 3%, okay, so this motor is connected to a mechanical load. So it is at full load. So the slip is 3%. Okay, so I'm just writing the information that is given in the question. Calculate the full load speed of the motor. So here NR is how much? This is what I have to calculate. So this basically this problem consists of two parts. So let's look at the first part, a prime mover rotating synchronous generator. So right now alternator and synchronous generator we have not yet learnt in this course. So just take it as a point that the formula Ns equal to 120 F by P also works in the case of a alternator or a synchronous generator. The same formula is applicable for synchronous generator as is applicable for the induction motor. So through this I can calculate the frequency of the supply. So let's do that now. So I use a different pen. So now the Ns is nothing but Nr because it's a synchronous generator. So 500 is equal to 12 poles 120 into F. So from this F I can find out. So this is 10 and then so F is 50 Hertz. So from this calculation I find the frequency is 50 Hertz. Now it is easy to calculate the synchronous speed for the induction motor. So again I apply 120 F by P. So 120 into 50 divided by 8. So how much is that? So I think a while ago we solved a problem like this, 8 pole. So 120 into 50 divided by 8. So 750 rpm. Now with 750 rpm, if there is slip of 3%, then what is the NR? Okay. So there is a direct way to solve it. See, because 3% is slip, the remaining 97% will be NR. So 97% of NS is NR. So I can directly solve it by saying NR equal to 1 minus S into NS. So this is 1 minus 0.03 into NS. This is nothing but 0.97. 97% of synchronous speed, which is 750 rpm. So how much is that? 750 multiplied by 0.97. So I get 727.5 revolutions per minute. Okay, so this is the speed of the motor. So this is a slightly complicated problem, but I thought it is based on the basic fundamentals. basic equation, Ns is 120 F by P. So with this, I'll stop here doing problems on the fundamentals of induction motor. We'll learn some more theory and then we'll go back to solving some more problems. I hope you are able to follow this. Thank you.